Hey everyone, here's our math problem for today. This is taken from the 40th German Mathematical Olympiad given in 2001, and this appears for grades 11 to 13, first day, problem number 1. And here's the problem. Determine all real numbers q for which the equation x to the fourth minus 40x squared plus q equals 0 has 4 real solutions which form an arithmetic progression. So we are after the value of this q. You can pause the video and see if you can solve this German Math Olympiad problem. Now let's solve this problem together. We have here a 4th degree equation, and we can simplify this by using variable substitution and turn this into a quadratic equation that is more manageable than this 4th degree equation. So we'll let u squared be equal to x to the fourth, and because of that, the original equation can now be written as u squared in place of u to the fourth minus 40u, where u replaces x squared, plus q equals 0. Let's call this equation as equation number 2. Now we want to find 4 real solutions. And so we let the roots of equation number 2 be r sub 1 and r sub 2, but both of them should be positive, and they cannot be equal because we want arithmetic progression. And so we have these conditions now. R sub 1 and r sub 2 are both greater than 0. R sub 1 is less than r sub 2. We impose the condition that both r sub 1 and r sub 2 be positive, because if u is equal to r sub 1 and u is equal to r sub 2, then since u squared is equal to x to the fourth, squaring now both sides here, we have u squared equals r sub 1 squared. But since this u squared is equal to x to the fourth, then x to the fourth is equal to the square of r sub 1. And solving for x is plus or minus the square root of r sub 1. It's important that this r sub 1 be positive, otherwise we'll have a negative number inside the radical symbol, and that will violate this condition that the roots be real numbers. The same explanation for r sub 2. Our r sub 2, here x is equal to plus or minus the square root of r sub 2. This r sub 2 must also be positive. Now since the roots of the second equation are r sub 1 and r sub 2, then the second equation can be written in the form the quantity u minus r sub 1 times the quantity u minus r sub 2 equals 0. We can expand the left side using the FOIL method, and here's the result. There's a common factor u between the second and the third terms, so let's factor out the u. This form now is what we call as the Vieta's formula. The coefficient of u is the sum of the two roots. The constant is the product of the two roots. Let's remember this result. Now, looking at equation number 2, the coefficient of u is negative 40. So this coefficient of u here is negative of the sum of r sub 1 plus r sub 2, which implies that this r sub 1 plus r sub 2 must be the same as this 40. This q must be the product of r sub 1 times r sub 2. Notice that we have here 4 roots for x. We have the plus or minus the square root of r sub 1 and the plus or minus the square root of r sub 2. Let's write all these 4 roots in order from the smallest to the largest. The smallest is the negative of the square root of r sub 2 because of this condition. When you get the negative of the square root of r sub 2, that must be the smallest value. Next is the negative of the square root of this r sub 1. The next is positive square root of r sub 1. And the largest is the positive square root of r sub 2. These 4 roots form an arithmetic progression. Then there is a constant difference d for each of these roots. Now let's analyze these 4 roots, and let's see if we can find expression for r sub 1 and an expression for r sub 2. Let's consider first this second and this third terms. Since there's a constant difference between these two successive terms, then we can now write this equation. The positive square root of r sub 1 minus the negative of the square root of r sub 1, that is equal to the constant difference d. Here minus and minus gives us plus. Square root of r sub 1 plus square root of r sub 1 is 2 square root of r sub 1, that is equal to d. Square both sides to get 4 times r sub 1 equals d squared. And solving now for r sub 1 is d squared over 4. And let's remember this result. Next, look at the first and the last roots here. To get this last root, we start with the first term plus the constant difference plus another constant difference plus another constant difference, or a total of 3 d's. The square root of r sub 2 is equal to the first root plus 1, 2, 3. 3d. Then subtract the square root of r sub 2 from both sides. Adding the square root of r sub 2 plus square root of r sub 2 gives us 2 square root of r sub 2 equals 3d. Square both sides to get 4 times r sub 2 equals 9d squared. And finally, r sub 2 is equal to 9d squared over 4. Let's remember these values as well. So here is now what we have so far. How can we find the value of d? Notice that r sub 1 plus r sub 2 equals 40. That means if we add this r sub 1 and this r sub 2, that is equal to 40, and we can now form this equation. So this expression here plus this expression equals this 40 here. Multiply each of the terms by 4 to eliminate the denominator. So we have d squared plus 9d squared equals 4 times 40 equals 160. 1d squared plus 9d squared is 10d squared. Divide both sides by 10 and get the square root of both sides. We have d is plus or minus 4. But since we arrange our terms from the least to the highest, then this constant difference must be positive. So we take d equals positive 4. So having known now that the value of d is equal to 4, we can now find the value of r sub 1. Replace d by 4, so r sub 1 is equal to 16 over 4 or 4. For r sub 2, replace this d by 4, so we have 9 times 16 over 4, which is simplified as 36. So we have the values for r sub 1 and r sub 2. We are now ready to find the value of q because q is equal to the product of r sub 1 and r sub 2. So getting the product now, we have q equals 4 times 36 or 144. And this is now the answer that we are looking for in this problem. Q is 144. To check, we know that r sub 1 is 4 and r sub 2 equals 36. Replace this r sub 2, this r sub 1, this r sub 1, and r sub 2 by their respective values. We now have these 4 roots. And simplifying, we have negative 6, negative 2, positive 2, and positive 6. Negative 6 plus the constant difference of 4 is negative 2. Negative 2 plus 4 is positive 2. And 2 plus 4 is 6. So it's verified that we have here an arithmetic progression with a constant difference of 4. And we arrive at this when q is equal to 144. And this problem is now solved.